Right, okay, let's make a start. I think there's still some people coming in, but we're just a bit over time, so keen to kind of get cracking. So good afternoon. Welcome to the first instalment of our innovation webinar series, Accelerating Rewilding with AI. I'm Kate Miller, Head of Business Growth, and I'm really excited to welcome our presenter, Ella Milne, Ecosystem Analyst for Ecosulis today. The format for the webinar will be roughly about a 40-minute presentation from Ella and myself, where we'll share our experiences of AI and how we feel it could be utilised in the rewilding and nature recovery sphere. I think, like most of you, I think we're still fairly new to AI and just kind of understanding how we can effectively integrate it into our business. So we'd really love to hear more about how you're all kind of using AI in your organisations, and also to explore if there's any opportunities for us to work together as well. For today's session, we'll be covering an introduction to Ecosulis for those of you that don't know us yet. AI and rewilding. Ella's going to share some case study highlights, look at and explore some risks and challenges of using AI, the future potential for AI, and I'm also going to introduce you all to an opportunity to join the kind of AgriBlue AI Accelerator Programme as well. So before we do kind of do a bit of a deeper dive into AI and innovation, I did want to take a moment just to introduce you to Ecosulis. And again, just for those of you that don't know us yet. So Ecosulis has been pioneering nature restoration for over 30 years now. And we've kind of evolved really alongside the ecological challenges and opportunities that shape the world today. We specialise in rewilding, ecosystem restoration and nature-based solutions. And we look to kind of deliver both environmental and societal value as well. Our approach is very much kind of grounded in science. It's guided by data and focused on outcomes. I suppose what sets us apart is our commitment to measurable biodiversity gains and also the restoration of natural processes. Whether we're designing projects or delivering them on the ground, we kind of focus on what works. So for nature, for people, and for long-term resilience. And our mission, whilst ambitious, is fairly simple. So we're looking to rewild half the planet by 2050, as we look to recover nature at scale. So we do this by combining kind of cutting edge science with practical restoration techniques, and everything from strategic rewilding frameworks to large scale habitat creation. We help landowners, policymakers and partners to move from intent to impact. And we certainly see technology, especially AI, as a powerful enabler of this work. That's why we're really excited to be leading at the intersection of ecology, innovation and delivery.
Thanks, Kate. Yeah, so as Kate mentioned, we obviously need technology to scale the work we're doing. And at Ecosulis, we spent the last few years investing in digital tools that make our work smarter and more scalable and helps make data-driven decisions. And this includes remote sensing, so we can monitor entire landscapes from space or drones, bioacoustic sensors, which let us hear biodiversity often before we see it, spatial modelling and GIS, obviously to map opportunities, risks and ecosystem dynamics. We also have a spin-off sister company, Credit Nature, who have developed a platform for nature positive investments. And now increasingly machine learning and AI, which is obviously where today's talk comes in. We're not a tech company, but we are becoming a company that's tech enabled. And we're doing that because the scale of the biodiversity and climate crises demands better tools to help, as Kate said, meet our mission to rewild half the planet by 2050. So we typically work with estate owners, farmers, NGOs, city councils, water utility companies, conservation organisations, and these are a few of the examples of the kind of rewilding work we do: natural capital mapping, rewilding vision planning, and river wetland restoration. And these case studies not necessarily with the support of AI, but these are the kind of projects that we're now looking to use AI to help us scale and optimize. So what AI is being used currently? So the field of landscape ecology has been using AI for many decades, mostly through the use of machine learning algorithms and often in quite technical or academic contexts. But now we're seeing this newest wave of AI, and it's really advancing the sector by enabling the processing and analysis of huge data sets with speed and accuracy. And this figure shows like a nested hierarchy of how these technologies are structured and how they relate to what we do in ecology. You can see at the broadest level, we have artificial intelligence, which is any system that mimics human intelligence. Within that is machine learning, where algorithms learn from data without being explicitly programmed. So in ecology, we use machine learning for things like species distribution modeling or predicting vegetation change, or things like agent-based models, which are simulation models to mimic behaviors of organisms to see how their actions affect the whole system over time. Then we have neural networks, which are inspired by how the human brain processes information. And these are good at handling non-linear relationships and complex data sets, which are things we encounter a lot in ecological systems. Then obviously deep learning, which is essentially neural networks taken to a whole new level, very powerful for processing large unstructured data like images, audio, video. And this is where things like generative AI come in, things like language models. So why should we use AI in rewilding? You know, AI and rewilding are two very powerful disruptive forces. They're both progressive and fast moving. You know, rewilding is, I think, reshaping the world of conservation, whilst AI is transforming, you know, nearly every other aspect of our world. But there's huge potential for these two forces to interconnect and benefit nature and society. And as we face the growing scale and complexity of rewilding challenges, AI is becoming a really important tool to help us tackle this. You know, traditional methods are largely based on human knowledge and experience. And while, of course, this is really essential, they're often time consuming, resource intensive, and difficult to scale at the pace that I think is required to reverse the biodiversity loss and tackle the climate crisis. I recently joined a SCIEM workshop in ecology, on AI and ecology. And one of the main takeaways was that we should be using AI for the mundane, repetitive tasks, you know, the easy kind of 80%, which can then free up our time for critical tasks and more important aspects that require that human element. So the main ways we see AI transforming our approach to restoration, you know, rewilding projects often span large or fragmented landscapes. Ecosystems are messy and complex and non-linear, and this scale and complexity can have significant challenges for traditional conservation methods. AI can help us tackle these challenges by improving the accuracy and efficiency of ecological monitoring. We can use advanced sensors, remote sensing, automated data analysis, and now we can collect far more detailed and reliable data than ever before, which is really exciting. But it's not just about collecting the data. We can also use AI to enhance our ability to analyze this information and identify patterns and insights that we might have missed, and also for evidence-based decision making. And this can include modeling those intricate interactions and in ecosystems, and also help us predict outcomes and design more effective nature restoration strategies. And then beyond the science, the capabilities of AI can also help us secure more funding and investment into nature recovery. You know, with AI, we can now offer measurable and scalable outcomes, which are really critical for attracting investment. So if we can provide clearer evidence of impact, it can enable innovative approaches like nature-based finance. So AI is opening new doors to investment and the support, and so that we can support large-scale rewilding projects, and crucially also enabling us to communicate those outcomes to fundraisers, partners and communities. But I will stress it's not just about replacing ecologists, it's about amplifying what we do and helping scale those solutions. So as Kate mentioned, we're definitely not experts in AI, but I thought it might be quite useful to go through some of the examples where we're starting to integrate AI at Ecosulis, and also where we see the potential in the future. I think there's huge potential for innovative and tech forward thinking companies to collaborate with AI developers and providers. You know, we need this interdisciplinary collaboration to progress in this field. So this is one example of where we've been using machine learning in our projects. We have been applying what's called a random forest machine learning model with data collected from LiDAR, height models, and field surveys to estimate above ground carbon stocks. And we've used this approach for a couple of landscape scale recovery projects. First off, we collect training data from field surveys. We measure things like tree height, trunk diameter, and species. And then we can use LiDAR data, which provides detailed like surface and terrain models. And then we process that data by first using something called watershed segmentation, which finds the edges of the tree canopies in the LiDAR data and then delineates the tree crowns. And then we can calculate predictive variables from those canopy dimensions. And then once we have this, we can run it through the random forest regression model to estimate biomass and therefore carbon of each tree. And the result is this output raster layer where each cell represents the estimated above ground carbon at that location. We're also using AI-powered tools to detect species using sound and images. We've been using bioacoustic monitoring and AI services such as wilder sensing to automatically detect and classify bird species. We've also used services like the BT acoustic pipeline to do the same for bat species. And we've also used AI tools for streamlining camera trap image analysis for efficient species identification. I think Wildlife Insights have recently released an open source AI model called SpeciesNet, which does this. And also image and audio-based apps like iNaturalist and Merlin can be used for data validation and also as a supportive tool for ecologists, as well as obtaining huge amounts of citizen science data. You know, crowdsourced data powered by AI can really help scale monitoring and also increase public engagement. So these tools massively reduce the time ecologists need necessary to spend in the field. It also helps us detect more species more accurately, as well as helping engage local communities. And then probably everyone's maybe used language models or is using language models. Tools like language models are having a huge impact. Ecosulis, we use them for text synthesis, literature reviews, sometimes idea generation. One really beneficial application we found is actually for coding as an AI-powered coding co-pilot. And this helps with things like ideation and debugging, which is really great because it saves a lot of time. You know, it doesn't replace our coding skills. It just helps us focus on the more important stuff. You know, we can quickly get suggestions for entire chunks of code. And a lot of people in the environmental sector maybe aren't coders. I've learned a bit of coding at university, but not to the extent maybe I'm using it now. So yeah, I think it can open doors a little bit for skill development, and it makes us work a lot more agile and collaboratively. We've also used language models for note taking. So this is also a good example of AI taking over the more kind of repetitive admin type tasks and freeing up our time to focus on the bigger picture. And then I think I mentioned already our spin-off company Credit Nature. They're currently building AI-powered data pipelines to assess ecosystem condition and change over time. They're using multimodal data, spatial data, visual data, audio data to generate robust metrics that feed into nature credit markets. So it's live, verifiable, data-driven approach to restoration finance. And by building AI-driven decision-making pipelines that collect data on restoration efforts, baseline ecosystem health, and we can design more effective rewilding management plans. And as these AI-enabled data streams continually improve, our ability to track ecosystem responses and optimize rewilding strategies is going to become more cost-effective and impact-focused. And then also some of the data sets we use in projects are already AI-derived. An example of this is Nature Scott's Bear peat mapping data, which uses satellite imagery and AI classification methods to identify bear peat across Scotland's uplands. And this data we applied in our Loch Lomond State of Nature report, and we selected it as an indicator of peatland condition due to the spatial coverage of the data, and also the potential for future monitoring through a standardized methodology. I think there's also something similar in the AI for Peat project, which uses AI to map peatland features across England as opposed to Scotland. These are also some other examples of a few other companies I know of using AI to scale nature restoration. There's Signature, how they've developed a smart microphone which automates the entire process from recording the sounds to analysing them, all integrated into a data management platform and dashboard. Loman, they offer tools that combine geospatial data and machine learning to monitor soil carbon levels and also biodiversity indicators, which is obviously so important for assessing ecosystem function before and after rewilding interventions. A company called AI Dash use satellite data and AI to monitor vegetation and manage biodiversity assessments. And they've developed a BNG AI system, which basically helps streamline biodiversity net gain assessments through satellite imagery and AI, which obviously saves a lot of time and reduces costs. And then the University of Cambridge are developing a conservation co-pilot, which will basically be like a chatbot designed to guide decision making towards the best solutions for conservation projects. And the co-pilot uses AI to distill like hundreds of millions of research papers into this conservation evidence database. So you, for example, be able to say, like, I've got a site of this type with these species of interest and I want to restore it or boost biodiversity. And then the chatbot would be able to provide recommendations. So the co-pilot is intended to aid human decision making rather than replace it. So as with any technology driven field, there obviously are risks and challenges, and I'm sure you've come across a lot of these. These are some that we see being the challenges potentially in the sector. First of all, AI models rely heavily on data, and obviously the quality of the model outputs is only going to be as good as the quality of the model, the data inputs. And in ecology, the data is often patchy, inconsistent, difficult to access or even find, as it's often not in one central place. Sometimes it's behind a paywall or there's licensing restrictions. So that we might end up training AI on incomplete or biased data, and we can then risk building systems that replicate those biases. For example, if a model has only seen data from well-studied habitats, it may perform poorly in more diverse or neglected landscapes, which could potentially lead to restoration decisions that may potentially do harm rather than good. Another example of this is this really interesting research paper. I'll pop it on the screen. They basically interviewed and analysed 30,000 responses from ChatGPT on ecological restoration, and they found that 2/3 of the responses or the chatbot's answers relied on the expertise of male academics from US universities, and only 2% of the responses were from Indigenous and community restoration experiences. So this analysis obviously highlights how the biases in AI-driven knowledge can, reinforce Western science and often overlook diverse sources of expertise and local perspectives regarding conservation research and practices. There's also, of course, ethical considerations such as data privacy. Another challenge is integration. A lot of ecological workflows are currently not designed to incorporate these technologies, so we need to rethink and redesign how we collect data. It's not just about the technology itself, but it's about aligning AI with practical restoration methods. When we use AI to guide decisions, such as tracking biodiversity, we must be able to verify those results as well. That means the models need to be transparent, they need to be peer-reviewed, auditable, and especially if they're being used to underpin funding or policy or reporting. This kind of brings us to the black box problem. So it's a common complaint of many machine learning models used in landscape ecology is that they're what we term black box. It means it's difficult to interpret how the model is determining the output. So you can clearly see the inputs and the outputs, but it's hard to, or it's not possible to see how the model gets from one to the other, or it's unclear. There's also a risk of over-reliance on AI for nature-related decision-making and potentially overlooking the importance of human expertise and ecological nuances that AI models might not fully capture. And then even when models work as intended, we still might misunderstand their outputs. And then finally, of course, we must consider the environmental impact of AI as well. It's a question that comes up a lot. My perspective is, yes, using AI models does have environmental costs, but so does flying drones, sending emails with PDF attachments, deploying a field team over a large landscape, or driving to and from site, many, many times. So the question we ask at Ecosulis is, does the ecological benefit outweigh the footprint? When used wisely, AI can really accelerate biodiversity gains far beyond what we could achieve with just human effort. So I think AI is a tool, and it does have to fit within the broader system of ecological ethics. We need to ground it in community, science, and long-term thinking. And our job is to keep asking questions about the trade-offs and also never let the technology lead the mission. So yeah, it is a trade-off. The key is obviously to ensure that the ecological return outweighs the carbon and energy costs. And I think things we can be mindful of. So the inference of AI or using AI is far less energy intensive than training AI models. So this obviously emphasizes the need for collaboration between AI developers and users. There's no point in us all trying to develop our own AI models if something already similar exists. Also selective and smart monitoring, just because we can now collect all this data and analyze all this data, doesn't mean necessarily we need to. We don't need to gather and analyze all the data just because we can. So that kind of leads to focusing on more ecologically meaningful metrics, which is what we try and do at Ecosulis. And again, as I said, always ask, does this tech lead to better restoration outcomes than if we were not using it? And with any new tech, there's obviously risks and challenges, but these present really exciting opportunities, I think, for startups to innovate, whether that's improving data quality or developing more adaptable AI models or creating AI-driven platforms to bridge these gaps. And at Ecosulis, we see AI as an assistant, not a decision maker, and we aim to keep nature recovery both data-driven but also human-centered. So where's this all heading? There's a few exciting areas we hope to progress in or kind of look to in the future. First, explainable AI. This aims to decipher the behavior of those like complex black box models to help us understand why and how AI models are making their decisions. So this transparency is really key for building trust and making sure that we are interpreting those AI outputs confidently. Also, continuing using generative AI. Would love to use generative AI to create like simulated three-dimensional landscapes that have been trained on real-world data, basically like creating what is called like a digital twin. You can mimic the structure, the behavior, and the context of natural systems, and it can be updated dynamically with live data. And then in landscape ecology, if you use digital twins with generative AI, we could start building scenarios of real-world situations and potential outcomes like wildfires and restoration management interventions, and explore the kind of possible futures for ecosystems. I know I think it's Ambios or the Devon Rewilding Network are using AI to like visualize different futures for the landscape along the River Dart. Also, natural language processing. That's AI that interprets human language from text, audio, and social media posts or news feeds, for example. And often in rewilding, there's a reliance on social media posts or volunteered content to capture perhaps like the social aspects of rewilding and understanding how people experience those landscapes. And that kind of information can't really be obtained from quantitative data. So natural language processes can be used to distill those forms of big data into more interpretable summaries. Carry on using geospatial AI, things like image segmentation and classification, and uses in pattern recognition from LiDAR data. Also geometric AI. So a limitation in geospatial AI is most approaches rely on like regular grid structures for landscape analysis, which can be limiting because many relationships in nature aren't just based on physical distance, they're non-Euclidean. So proximity in nature might be defined by genetics or social connections or ecological interactions. So that's where geometric AI comes in. We can use geometry and spatial autocorrelation to handle irregular data and these kind of complex spatial relationships, making it a pretty powerful tool for understanding the real structure of landscapes in ecology. And finally, a pretty exciting one is robotics and kind of autonomous data collection, especially things like drones outfitted with like customized sampling equipment. I think this has huge potential for field data collection in remote or challenging areas that are difficult to access. Researchers are experimenting with robotic systems that can cut and sample leaves and other plant material and like capture specimens on sticky paper. there's also like underwater drones. There's something called the Snot bot, which has been engineered to collect whale and dolphin blow from petri dishes to analyze marine health. And yeah, so these fully kind of autonomous systems can learn from the data they're collecting in real time, which can then lead to real-time decisions or changes in sampling strategy, which I think is really exciting. And yeah, so in terms of some of our key takeaways, firstly, I think translating AI outputs into actionable insights is crucial. You know, I've mentioned AI can generate huge volumes of data that we didn't have before. But that data only becomes valuable when we can interpret it clearly and use it to inform decisions on the ground. Data validation and quality control by human experts remains absolutely essential. You know, AI models are only as good as the data that they're trained on. So I think we need rigorous checking and ground truthing at this point, especially to build that trust and ensure accuracy. Obviously, collaboration between AI developers and users, ecologists, local communities is pretty key when making use of this technology. You know, when we bring together the technical expertise and the on the ground knowledge, we'll be able to make solutions that actually work for the real world. Also, local community involvement is pretty important for providing that context and verification. I think we need to make sure we are considering different perspectives, which sometimes AI can overlook. And of course, there's got to be that accountability and transparency. We need to be responsible in how we use AI, especially when it influences funding and policy decisions. But yeah, probably the most important takeaway is that AI should be seen as a tool that helps ecologists, not replaces them. And at Ecosulis, we don't want to rely on AI alone. Instead, you know, it's about using AI to boost what we do, speeding things up, taking over those repetitive and mundane tasks so we can kind of focus on what humans do best, which is the creative problem solving and complex judgment calls, empathy and local knowledge. So yeah, it's all about balance and trust. I think AI can give us really powerful insights, but it can't yet understand the complexity of nature, you know, like humans can. So I think, yeah, it's really about combining AI's strengths and ecological expertise to make smarter and better decisions. But yeah, I think the human element has to stay front and centre. Back to Kate.
Thanks, Ella. Yeah, so in this section, I'm going to explore a bit more about how we position AI, not just as a kind of standalone feature, but as a strategic asset. So one that kind of looks to support client goals, enhances ecological outcomes, and just adds value really across sectors. And I think as AI continues to evolve, so do the opportunities to embed it meaningfully into the work with our clients as well. I think certainly when it comes to securing funding and kind of winning bids in the nature recovery space, I think clarity, credibility, and innovation make all the difference. And certainly utilisation of AI can bring all three into your proposals in a really powerful and evidence way. I think firstly, you can kind of look to strengthen funding applications with AI-backed insights. That means you don't just talk about ambition, you bring data into the table. AI can also be used to analyse kind of satellite imagery, biodiversity trends, soil health and carbon potential, as Ella mentioned. And this gives kind of funders a clear picture of what's possible on any given site. And this in turn will kind of build confidence in the feasibility and also the long-term value of your plans. And secondly, I think focusing on demonstrating measurable impact and innovation. So AI can enable us to model expected outcomes like species recovery, carbon storage, or flood resilience before work even begins. This can then allow us to kind of show predicted baselines, simulate different interventions, and build in automated monitoring from day one. And I think that ability to demonstrate impact with such precision kind of helps you to kind of stand out in a really highly kind of competitive market. And I think, and thirdly, aligning AI solutions with client priorities. So regardless of the client, regardless of the sector, you can kind of tailor your AI tools to solve their real world challenges. So, for example, you know, kind of helping a water company identify natural flood management zones or supporting a council in achieving measurable biodiversity net gain. AI can kind of help you to speak the same language as your clients. It's data driven, it's risk aware, and it's outcome focused. I think it's important to reiterate, you know, AI isn't just another feature to add. It's not just another gimmick to go, oh yeah, we're kind of integrated, we're using AI. It really is a strategic tool if it's used properly. It can really help you to kind of design stronger, more compelling proposals that will certainly hopefully help you to win support and deliver lasting change as well. And I think once you've built AI into your offering, I think the next step is definitely absolutely helping your clients to see the value. So that will certainly mean, and even just with Ella talking, being able to kind of translate technical capabilities into real world outcomes and benefits. It can be quite overwhelming, I think, sometimes with kind of the jargon and the different types of AI that you can use to really understand how you can apply it. I think so. The key thing here really is to kind of avoid overwhelming clients with jargon or complex models, and instead focusing on what matters to them. So whether that's kind of faster planning, whether that's smarter land management, or kind of better biodiversity outcomes. I think, for example, we might show how kind of AI reduces manual survey time by, say, like 60%, or kind of helps target interventions that can kind of deliver the highest ecological return. I think it's about building credibility kind of through pilot projects and case studies. Clients kind of want to know that it's not just theory. They want to know how it works in the field. They want to know that it's going to work for them. So kind of being able to showcase real examples is really important. I think rewilding sites where AI has supported kind of decision making, automated kind of monitoring tools have already kind of delivering on insights, or even kind of species recovery programs, how they've optimized with predictive models as well. I think these stories can all help to kind of build that trust and build that evidence in the technology that you're putting forward to your client. And I think finally as well, the biggest one is to understand the procurement process and partnerships really carefully. I think many clients have kind of procurement systems and kind of have kind of favourable, proven, scalable and compliant solutions as well. So I think you've got to be sure to kind of position your AI tools not just as kind of tech kind of demos, but as kind of strategic assets and how they align with their existing processes as well. This kind of might mean kind of co-designing pilots. It might mean offering integrated support or develop shared outcomes frameworks as well. But ultimately, I think by speaking their language, kind of being able to back up your results, you can help kind of AI to move from a kind of innovation kind of buzzword really to a really trusted enabler of ecosystem restoration. And as I'm sure all of you will kind of know, rewilding rarely kind of happens in isolation. It certainly involves a kind of mosaic of actors, so kind of NGOs, local landowners, corporate sustainability teams, researchers, and increasingly kind of tech startups as well. I think AI serves as kind of a connective layer between those. It kind of helps integrate data and decision making across these groups. So whether that's kind of aligning biodiversity goals, whether that's kind of optimizing land use planning or tracking conservation commitments. For instance, an NGO might use satellite data to monitor ecological baselines, while a corporate partner uses kind of AI to access nature positive supply chains. And I think with a shared kind of data platform powered by AI, as Ella's kind of shared through Credit Nature, they can coordinate in real time and ensure that their actions are aligned. I think rewilding is no longer just about isolated pockets of restoration. It's about designing for a whole entire ecosystem. And I think AI models can process kind of satellite imagery, biodiversity data, and client projections to identify those priority areas in intervention. It can simulate how species and habitats will respond over time and also flag unintended risks as well. And I think importantly, AI can also help with monitoring and impact assessment too. As Ella mentioned earlier, from kind of acoustic sensors that track wildlife return to drones that map kind of vegetation changes, AI converts vast data sets into clear, actionable insights. And I think this allows us to kind of improve transparency and accountability, which is absolutely crucial for funders and policymakers, being able to understand what the risks are, being able to kind of see what's in the horizon and being able to kind of plan their kind of funding around that. I think we're now seeing a real kind of surge in innovation, and I think startups in particular are building tools for kind of biodiversity measurement, AI-powered restoration modelling, and carbon monitoring as well. And I think ultimately the challenge here is just that integration. I think AI can help certainly startups and other businesses, I suppose, to connect by kind of aligning their solutions with open data platforms, ecosystem models, and existing delivery frameworks as well. I think kind of for an example, a startup offering kind of AI-driven soil health analytics could feed their data into a national rewilding platform, either used by the government or other NGOs. And I think this is where we can really scale. I think because AI isn't just it doesn't kind of just automate or optimize, it kind of enables that collaboration, that coordination, and also that confidence, I think, in the rewilding journey. I wanted to kind of conclude really our presentation today by just kind of also introducing you to kind of AgriBlue AI Accelerator Programme. So Ecosulis, we certainly believe that kind of nature-based solutions are absolutely central to creating food systems that are both resilient and regenerative. And that's why we're proud to sponsor Brightside AgriBlue. This is a pioneering initiative that brings farmers and AI innovators together to transform how we approach agriculture and aquaculture with biodiversity, climate resilience, and also long-term impact at its heart. As a UK-based rewilding and nature recovery consultancy, our work spans across everything from kind of practical habitat restoration to cutting-edge rewilding strategy. And I think through the AgriBlue programme, we'll be looking to kind of offer mentorship and technical insight to startups working on AI-powered solutions. We're especially excited to support ventures that align with our systems thinking approach as well. So where technology, ecology and communities all work together. So I appreciate you're not all startups on this call, but if you are a startup, if you know of a kind of startup, I think this programme could really help to accelerate your journey. For this accelerator programme in particular, applications are now only open until the 15th of July. So there is still a little bit of time. So if it's yourselves or if you know somebody and you'd like to get involved, please let me know. I'll be happy to introduce you to Brightide's founder and CEO, kind of Harry Wright. I think he's on the webinar today, but happy to kind of pass on his details if anyone is interested or if you know of anybody that's interested. And that kind of brings us to the end of our presentation. Thanks, Ella, so much for sharing your knowledge and expertise with us. I hope you've all found the presentation insightful and kind of thought-provoking. I think we've probably got a little bit of time to have a look at some of the questions. If you can bear with me, I'm just going to have a look and see what we've got in and see how Ella might be able to answer some of those. Do you see how I'll put you forward straight away, Ella? And I didn't position myself as the AI expert there. Let me have a little look. Okay, so I've got a question here from Jordan Davies. He said, I'd love to know more about what role AI can play in identifying invasive species, or tracking their spread in urban or semi-urban catchments.
Ooh, that's a good question. I think actually probably for invasive species more than a lot of species, probably because there's so much data on invasive species, or we love collecting data in the UK on invasive species. So again, as I mentioned, like obviously the model, if you're creating a model, the output's only going to be as good as the input data. So yeah, I think there definitely is. I wouldn't know specifically what kind of models to do, but I'm sure some of the techie AI, geospatial AI companies would have. I know Lohmann look at biodiversity, or they create bespoke AI models to look at biodiversity spread. So yeah, no, I definitely think there is a definite role for AI in there. Not sure if that answered it very well, but
thanks, Ella. I've got another question from Zach. Do you have any site recommendations where we can find and explore AI tools and software that we can apply toward environmental science and conservation? How do you find appropriate and available tools? Should we ask ChatGPT? What was the first part of the question? Sorry, do you have any site recommendations when we can find and explore AI tools and software that we can apply toward environmental science and conservation?
Yeah, that's a good question. I mean, there's so many that pop up now. I feel like a lot of the time I've learned from them just from like speaking to people who are using them. Potentially you could ask ChatGPT, a quick Google search, I guess. But yeah, I don't know of any site recommendations specifically. But yeah, there's a lot out there. Potentially ask ChatGPT.
Brilliant, thanks for that. I'm just answering.
Oh God.
They're all coming in now. Joseph, are there any tools or programs focused on use of AI and project monitoring through either satellite data or water quality?
Oh, I don't know the answer to that one.
Okay, we'll definitely find out for you, Joseph. We'll kind of
any of the answers of these we'll send an email out.
There's a question from Elaine. Has your model that looks at above ground carbon been applied to the underwater environment, please?
Not specifically. The model that we use for above ground carbon is specifically designed for the input parameters are to do with above ground carbon, but there are definitely models. Again, I'll say Lohmann have been looking at below ground carbon Obviously, that's through soil sampling. So I think a lot of the same models can be applied, but the one we've used for above ground carbon is specifically for above ground carbon. Again, it depends on the input data required. Yeah.
Brilliant. Thanks so much, Ella. Right, thank you. I think I've covered everything. If not, we will come back to you. We can contact you directly if anything that we've missed. We do normally send out some resources kind of post-event as well, that might be useful, kind of background reading for you. And as Liv said, we'll be recording it and we'll send out the recording to everybody. Please do stay in touch. If you think of any other questions, please feel free to email us. And if you would like some introductions to Harry, I think he's popped his email in the chat, but also happy to kind of coordinate some introductions as well. Thanks again, Ella, for joining me today and leading our discussion. And thank you all for joining us. And I hope you have a great afternoon and hope to see you again in our future webinars. Thanks, everybody. Take care.